Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science.
Hello and welcome to CTDS.show, the show bringing you quarantine content, having interviews with my machine learning heroes for you to enjoy. Now, without more self-promotion, I want to talk about this episode with another legend on Kaggle, the first ever Kaggle's Kernel Grandmaster, someone whose storytelling I have personally enjoyed a lot, and I'm sure when I can speak for the community, has provided a lot of benefit to the community. Data scientist at Edison Software, Grandmaster Heads or Tails, Martin Henze. In this interview, we talk about his journey into data science, his transition from astronomy. Astronomy involves a lot of looking up to the skies and trying to figure out through data what's out there. And I try to draw, as you can imagine, many parallels between astronomy and data science. And his approach to creating the amazing kernels. If you're not familiar with them, please pause this interview right now. Go to his profile on Kaggle, check them out. They're really worth your time. We also discuss his transition into doing data science during the day. There are also, I believe, a lot of rich, hidden, golden advices for people that aren't working towards sharing their kernels on Kaggle. Now, without further ado, here's my interview with Kaggle legend, the first ever kernels grandmaster, Heads or Tails, Martin Henze. Please enjoy the show. Hi everyone, I'm really excited to be talking to another Kaggle legend on the show today, Heads or Tails, Grandmaster Heads or Tails, Martin. Thank you so much for joining me on the podcast, Martin.
Thank you, Sanyam. It's my pleasure to be here. I'm a big fan of your show, and I'm really happy to finally be on it.
Really excited to be talking to you. We were supposed to meet in person. Unfortunately, COVID didn't let that happen. So I'm really enjoying the chai that I was supposed to give to you. I have that in my cup right now.
Well, for the time being, I have to do with my own tea. So cheers.
Cheers. I want to start with a question from Rohan Rao. It's simply heads or tails.
Well, you might think this is a simple question, but as all the big philosophical questions like Python or R, TensorFlow or PyTorch, this is something that you can't answer with a simple answer. It depends, it's a yin and yang, light and dark kind of way. It depends on the situation. It depends on the question of the day, on the specific question that you're being asked. So it's both heads and tails, depending on what's happening.
Okay. I'll maybe have to go back and listen to that answer to understand it. But I want to now start off by talking about your background. You have worked as a postdoc researcher in astronomy. So I want to ask you this question. Astronomy involves a lot of looking up to the skies and trying to figure out what's out there. This is my understanding of it. So please excuse me if I'm wrong, but trying to understand through data what's out there. How would you compare that, if I may, to discovering insights with data sets? Do you see any parallels?
Oh, there's a lot of overlap. I mean, when it comes down to it, data is data, really. And astronomy is a very observational science, astronomy and astrophysics, right? We look at the sky, as you say, and we try to observe as much as possible. It's a physical science. We have physical models that go into it, but unlike other physicists, we can't really set up our own experiments in the lab, right? We can't build our own stars in the lab. That's not possible. Maybe, it's a good thing that it's not possible. Might be a bit too dangerous. So we observe, and we try to observe as much as we can. And from that, we get our insights and we get our ideas. So what you get is a lot of data. It's a lot of imaging data. Just kind of image the night sky and see what sort of objects can you detect. There's a lot of time series data in that you kind of observe the sky over a longer time period and see whether there are any changes, which is one of the most exciting things because there are a lot of changes depending on what kind of objects you look at. The sky can be very, very variable. And you bring that all together. You have a lot of statistics. You have a lot of data to begin with because there is a lot of sky, right? There's too much sky, in fact, for us to observe all at the same time, right? That's why we sometimes get these notes about small bodies coming relatively close to the Earth, right? That we only see a couple of days before. I mean, none of those are really a danger, are really a problem, but it just illustrates how much sky there is. So we have a lot of data, and astronomers always had a lot of data, beginning about 100 years ago, right? And always tried to use the cutting edge techniques, which at the time were just, statistics but also data cleaning, data wrangling with a very pen and pencil and paper way. And for that reason, we've kind of been used to working with data and extracting insights from data. And that's exactly what we do in Kaggle as well, right? We have our special methods and tools and methodologies in order to extract as much insight as possible from the data that Kaggle gives us. And in astronomy, we're doing the same, just that, instead of Kaggle, it's the universe that gives us a lot of interesting data, and we're trying to understand what's going on out there in the cosmos.
So I maybe I discovered an Easter egg in your Kaggle profile. Your PhD was included a study of the Andromeda galaxy. Is that your profile picture on Kaggle and Twitter?
It is not.
Oh.
It is not. I thought about it, but I thought it would be too obvious. No, it's another relatively nearby galaxy, a galaxy that we kind of see face on. So we see the spiral structure directly. And it's a big, beautiful spiral galaxy, Whirlpool galaxy. It's not Andromeda, but Andromeda looks very beautiful as well. I can recommend it.
Okay. Now I want to switch back in time to your astronomy days when you were just working with astronomical data. Can you tell us about that journey? Why did you pick that path? And now you sort of segregated your astronomical experience into time series, image-related data. Were you familiar with those terms even back in the day, or did you find out that, hey, this is something I already know about when you actually started Kaggle later on?
Yeah, so those terms I already knew. The little fun fact is that in astronomy, when we talk about time series, we call them light curves because that's what they are. They measure kind of the light of a star over time. So they're a curve of the light. And all these terms exist essentially. And in astronomy, it was the first time that I really got into contact with data and that I really got into contact with projects that involved a lot of data. It involved a lot of data preparation, a lot of data analysis, data cleaning, of course, and different methods. So my master thesis, essentially, was based on analyzing a large stack of historical observations. And those observations were made before the age of digital cameras. So they came in these large glass plates, photographic plates, that were really physically large, and that were taken off the Andromeda galaxy between 1960 and 1995, more or less, with one of the largest telescopes in Germany. So they looked at the galaxy over and over again, hundreds of times during these years to observe the galaxy itself, but they also observed a lot of stars within the galaxy, variable stars, exploding stars. And that's what my thesis was based on, trying to find those exploding stars and study their light curves, study their time series evolution. And that's not an easy task because those big plates, they contained hundreds of thousands of stars, like 200,000, 500,000 stars that you could detect just in the image. And I was looking for the 1 or 2 stars in that image that would change their brightness very strongly over time. So it was a bit like looking for a needle in the proverbial haystack. And that's what made it interesting. And that's what made it challenging. And that required a lot of data analysis techniques, data cleaning techniques, in order to extract those couple of dozen stars that I ended up finding from this massive set of millions of stars over all those photographic plates. So that was my gateway into database projects. That was my first database project. And I was really hooked. I was hooked on data, and I was hooked on astronomy.
Okay.
And that's why I spent the following 10 years working in astronomy. And I still think it's a very fascinating field. And now I'm kind of transitioned more into the data field.
I want to linger on to that point. I read you studied about X-rays that were coming from these galactical activities in the Andromeda galaxy. Could you speak about the techniques that you were exposed to, pun intended, at that time while reading about this? And that'll also allow me to transition into how did you pick up different techniques when you joined Kaggle?
Yeah, so you're right. I started with optical observations, these big glass plates. And then for my PhD thesis, I started to work with X-ray observations. So the thing about, so X-rays are just another type of light, right, of electromagnetic radiation. But different from the light that we see with our own eyes, X-rays are very energetic, which means that X-rays are produced in processes that are very energetic as well. So X-rays come from stars that are not as nice and calm and peaceful as our sun, but from stars that have very high temperatures, very high gravity, where very violent processes are happening, right? And this energetic universe is much more variable. It's much more violent than the universe that you can see with your eyes when you just look up at the night sky and everything looks unchanging from night to night, really. It isn't, but it looks like that. In the X-ray universe, there are, very, very strong changes from time to time. And X-ray detectors, they also work differently from optical telescopes because these energetic photons you have to treat differently than the normal visual ones. So that was a kind of a change in methodology, in a sense, that from these optical observations, I moved to X-ray observations, and I had to deal with a world where now you would end up counting photons. So I had literal observations where I counted 10 photons, right? And I said, yeah, that's a detection. That's a new object. That was enough signal because the noise was so low, because the telescope was so good that we could say, okay, we can do something with that. And the running joke in X-rays is really that with 2 photons, you have a detection. With 3 photons, you have a light curve, so a time series. And with 4 photons, you have a spectrum, so kind of an energy spectrum, and you can try to analyze it. And it's mostly a joke, but there's a little bit of truth to it as well.
Also sounds really fascinating.
Yeah, and you're right. It's a different world in a sense. You're looking at the same objects, but they look very, very different in these high energetic rays.
Makes sense. Now I want to transition into your Kaggle journey, and my questions are based off on 2 of your Kaggle interviews, the blog one and the recent profile. What made you take the jump onto Kaggle? Why did you decide to sign up on Kaggle and start creating the amazing kernels that now I'm sure at least all of my audience should know of? If you don't, please go to his profile and check them out even before continuing with the interview.
I'll wait for you to check them out. Yeah, so my history with Kaggle, or my knowledge of Kaggle, actually goes back further than when I joined. I had been aware of Kaggle for quite some time, I think it was first in 2012 when I stumbled upon Kaggle. I didn't join at the time, but I was aware of it because I think they were running some astronomy related competition, and I just stumbled on it and I thought, huh, that's cool. You actually, you don't have to do the research yourself. You don't have to do the analysis yourself. You can just, ask a lot of smart people around the world to work on that project for you. And I started looking a little bit around on the platform, and I found it very interesting. And I almost got hooked 5 years before I finally did. But at the time, I was in the process of moving to a different country to start one of my postdocs there, and so it didn't make it high enough up the list of priorities for me to actually take the step into Kaggle. It would have been very interesting if I did it at the time. But I was always aware of it. It was always at the back of my mind. It's something that, that's interesting to explore. And I finally ended up joining in 2017 at the time where I was in between postdocs.
Mm-hmm.
So I had just finished one of my postdocs in Spain, and I had another one lined up in California, where I'm now, essentially, just a little bit more south. And I remembered Kaggle, and I thought, well, I have a couple of months in between jobs, essentially. This is a good time to get into it. This is a good time to get started. But if you know, kind of in our academic world, the fact that you don't have a job at the moment doesn't mean that you're not working on these problems, right? Just because you're not paid doesn't mean that, you don't have any observations or anything to analyze. You're still writing your papers. You're still getting your data. So that was something that I would do during the day.
We can't stop a thinker's curiosity.
Yeah, there might also be a little bit of the old publish or perish situation. But no, just because there's a kind of a few months of funding gap doesn't mean that the data isn't incoming anymore, or the papers don't have to be worked on. So that's what I would do during the day, essentially, ironically, seeing that as astronomy. And I would kind of work 4 or 5 hours during the day, and then I kind of would put that project down, and I would in the evening and during the night I would start looking at Kaggle. And my idea was at first that this is a great place to learn more about the state-of-the-art techniques. Right? I wanted to, for all these time series, for all these light curves that I was looking at, I wanted to learn more about how to analyze them, how to classify them in a big data kind of way, right? That I don't have to do too many manual or too many custom analysis, but I could try to find the needle in the haystack in a more clever, in a more automated way. And that was one of my goals, also to learn more about machine learning, because at the time, machine learning was getting more and more popular, and you kept kind of hearing it here and there, and different papers, different crazy results, and I wanted to know more about that. I knew nothing about machine learning essentially at the time, right? And I wanted to know more about that. And then, as it happens so often, the more I got into Kaggle, the more I got interested and exposed to all the different fascinating problems and fascinating projects that were happening there. And I got, really, really into it and really interested in contributing and finding out more. And the community really, really helped, which is something that I'm going to say a couple of times during this interview, because it's so important. That the fact that we have such a great community made out of people who are not just smart, but are very friendly and very warm and welcoming and accessible and helpful, it makes a world of a difference when you're new, when you're trying to get into a new subject and trying to learn something. And it's so important, and it's so valuable.
Certainly, it's truly the home of data science, as they title it. We'll just talk about that in a bit. But what are your thoughts on when is a beginner ready to share their work on Kaggle? Someone who's just joining the platform, trying to share their work.
under physical isolation? When should they feel ready to be able to share their work?
I think everybody works at their own pace, right? Everybody does projects at their own pace and at their own comfort level. But I would recommend to share a little bit earlier than you're comfortable with, because there is a danger that's perfectionism, right? You can always tinker a little bit with a certain kernel, with a certain analysis. You can try to make it a little bit better, but those are only very small steps. So you want to share a little bit earlier than when you're happy with the kernel, just to see from other people's feedback and reactions whether you're going in the right direction, whether the kind of the grand scheme of what you're doing makes sense, and whether the tools that you're using, whether you're using them correctly. And I don't mean put out something that's half-baked, or something that you just wrote in an afternoon. Put a little bit of thought in it, but don't overthink it, right? So there's a balance between putting some thought in it and trying to polish something to perfection, which might just not go in the right direction in the first place. So as a beginner, I would say pick a project. It doesn't really matter which one, but of course there are these great starter projects that we all did, like Titanic or House Prizes. Pick one of them, make up your own mind, read some kernels if you need inspiration, but make up your own mind how to approach the problem, how to solve the problem, and write up an analysis. It doesn't have to be shiny. It doesn't have to be pretty. It just should answer some of the questions that you have about the problem, that you have about the data set, and put yourself out there and look for feedback, look what other people are doing, and start interacting with the community. And that will give you many, many more ideas and many more pieces of inspiration to work on.
I couldn't agree more. In the startup world, we call it 80% perfect is just good enough. Just go ahead and publish. Don't wait for it to be 100% good. What are your thoughts? And you had hinted this in this interview also, and in Kaggle's blog interview, you had mentioned that the Kaggle community was very helpful with the feedback. So someone who's just starting out, they really need feedback. They want to get their work out there and get experts' opinions, their ideas. What's in your opinion the best way to engage with the community? How should someone ask for feedback or when they put their work out there? For example, a kernel, if I may.
Right. I realize that as the community is growing, things are becoming a little bit more easy, but things also become a little bit more difficult, because we have many, many more kernels now than we had a couple of years ago, and many more people, but also means that many more people who read other people's kernels and who can give feedback. So the important thing to remember is really that it's a two-way street, right? You're not just on Kaggle to put out your work and look for other people's feedback, but you're also there to give feedback to other people and to communicate with them about their work. So what I would recommend is, if you're at that stage as a beginner with your first project, put your first project out there, put out something that you're reasonably happy with, but you think that might, need some input, and then just start interacting with the community. Look at other kernels, give some feedback there, participate in the forums if there's a certain question that you want answered. And more often than not, if you put something out there that's original, which is important, and that's yours, then people will look at it and will give you feedback. So this is what I think of the more natural way to do it. And to kind of underline more that natural aspect, what I'm not recommending is to go around and to put comments or discussions everywhere saying, hey, I made this kernel, look at it. This kind of advertisement, which has increased a little bit too much in Kaggle in the most recent times, it's not a good thing. Right? You want to interact with the community in a way that you give valuable feedback and then valuable feedback will come back to you. It's a natural process. You don't want to turn it into an advertising project, because people on Kaggle, we know about data. We know how these things work. We realize when somebody is, and I have to say, spamming, and people who are doing these kind of spam things, they are not highly regarded. So you don't want to do that. Be genuine. Just focus on the issues. Focus on the projects. Give your own feedback, and feedback will come back to you. I guarantee it. And even more so that already works in the starter competitions like Titanic or house prizes, because people are engaged. But it works even better once you decide to join a live competition, because if you join a live competition, everybody essentially starts from the same place. I mean, some people, of course, have knowledge about tools that's more extensive than yours. Some people might have some domain knowledge that's more extensive than yours, but that will always happen. But in terms of the problem, we all start, with looking at a problem for the first time and thinking, oh, how could I possibly solve that? And if you have an interesting idea, if you have an interesting kernel or an idea that you could put out in the discussions, then that will be useful for everyone. So if you're engaged, if you really contribute to the community there, then the community will appreciate it and will give back to you.
I like to think of engineering as an art of sorts. Data science is the art of data, if I dare say so. And if I had to draw a parallel, it's literally like an artist carrying their painting around and showing it to other artists. Hey, what do you think of mine? Instead of just discussing art with them. And that's literally annoying in some sense. That's where I think it, and I agree with you that it's also a spammy behavior. And I think people fall into that trap because they really, some of the people might want to have some attention on their kernel because they've put out some work. But like you said, if it's really genuine, it might take a little while, but it does get picked. And people like you have also started a thread where they're trying to, and especially you are trying to find underrated kernels, and the community is great at that if the person creating the kernel is very genuine.
Yes, and there are a lot of these hidden gems, as I like to call them as well. So yeah, I just started this new series in which I try to find 3 kernels every week that I think are underrated. I think they're really good. There's really quality there. But if you look at the votes or the comments or the engagement that those kernels have received, they're underrated in the sense that there could be more people looking at them, more people engaging with those kernels, and also more people learning from them, really. So I'm kind of trying to do my own small thing to bring a little bit more balance to the community in that sense, that we try to focus a little bit more on the quality instead of kernels that are being spammed or things that are very basic, but for some unknown reason have a very large number of votes.
I'll definitely have the thread linked in my show notes, so audience, please check it out if you want to take a look at it. I now want to talk about your process of creating kernels. How do you start with a blank notebook? What are your first steps when you're just starting with a blank Jupyter notebook? You're trying and you have the data set loaded. How do you approach any data set or any problem in general?
Let me be snarky here for a moment. I don't start with a Jupyter notebook. It's not my favorite kind of environment. I'm an R guy. I make this, sometimes sarcastically clear. And I like Python. I like Jupyter, but I think there are better IDEs out there. So please don't hate me for it. But just a little side remark. I think that when it comes to a new project, so as I said, we're all starting more or less from the same point of view. We're starting with a new data set that we haven't seen before and that we want to analyze. And every data set is different. We know that very well as well. But there are some similarities from data set to data set that we can make use of. And those are the steps that I pretty much follow in every kernel. And I think the only project that I started really from scratch without knowing what to do was Titanic, was my first, Kaggle project, and many people's first Kaggle project. And ironically, I just remember that I did start that in Jupyter Notebook. So, to apologize for a snarkiness now, I assume. So there are some fundamental aspects about data sets that you can always start with, right? You start with a very high-level, big picture overview. Let's talk about tabular data sets, because that's what I mostly have worked with, and there the parallels are really easier to find. But the steps themselves, they also translate to NLP, they definitely translate to time series, and in a sense, they also translate to imaging problems. So you first want to know about the general structure of the data, right? And that can be very easy. How many rows, how many columns, how many missing values? What are the types of the features that you have? Numerical features, categorical features, how many of each? These kind of things is what you want to look first at. And then the goal is really to get a bird's eye overview of the data. And for that, I use visualization extensively. But that might just be my preference, because I'm a very visual person. It really helps me to see the data spread out and the data dissected on several axes, and trying to see those relations, see those distributions. But for other people, it might be useful as well, right? So you could start out with just plotting the distribution of the target value, right? That already tells you something that just by feeding the data into your model, you might miss. So you might see that that the target is normally distributed. Yay, everything is fine, and it will never happen. Or it might be log normal, or it might have some weird distribution, or it might be imbalanced, right? If you have a classification problem, it might be very, very imbalanced. And if you didn't know that, you might feed it into your model, and you get 98% accuracy, and you're very, very happy. And it's absolutely useless because it's imbalanced. So these kind of fundamental things is something that you look at first, and you want to try out and find that at the beginning, because you don't know anything about the data yet, and you want to see what are the fundamental properties. And you can do a similar thing for the different predictor features. You can just plot the distributions, see what they look like, see whether there's anything interesting there. And once you know that, I think then you can start look at interactions between the features, see whether there is an easy impact or an obvious impact that your target has on one of the predictors, something that you can then start to exploit for modeling. Look at correlations, look at multidimensional plots, take the different features apart, correlate them with each other, put them in relation to each other, and try to understand what's really happening in your data. Try to have a deep look into your data. So it's a multi-step process, in which with each step you go deeper into the data. And with each step, I can guarantee you will get more ideas, and you will find more features of the data and more oddities that you can then decide to explore further if you want to, right? You see something that, this correlation looks odd. I can try to split it by that other feature and see what's the impact is there. Maybe I can find a clean separation or something like this. Those are the kind of the typical discoveries that you will make. And then from data set to data set, they are more or less important. And you will follow the more important ones, and you will get to a more kind of complete understanding of what your data set looks like.
I can also see a parallel, like you mentioned earlier. You were used to visualizing the X-ray data, the I think you called it the images or the stars on this glass lab, and I can see the parallel between data visualization. Do you think that's also an originating point of your love for visualizations?
It might be. I mean, the astronomical data essentially arrives in images. So whenever you get a data set from a telescope, you get a set of images. And for normal optical data, those are really just images as you imagine them to be. So that the ones that you can find when you Google for Hubble images and you see these kind of beautiful large fields of galaxies and stars.
Yeah.
And for X-ray data, another little fun fact, it's actually a data cube that you get, because an X-ray telescope doesn't just accumulate all the photons that you get like an optical detector does. But for each photon, for each single photon, it measures the XY coordinates plus the time of arrival plus the energy of the photon. So it's a four-dimensional data set that you get, and you can take this four-dimensional data set, you can kind of squish it down to 2 dimensions of space and just look at an image, or you can kind of take it apart and essentially you could look at the time series of all objects in the image simultaneously. But depending on how many objects you have, that's not realistic. So there's some kind of slicing and dicing of data.
Data transformation techniques.
Data transformation, exactly. Data extraction. And then, but it's a two-stage process, because what we would typically do, or what I would typically do, is to take these images and then turn these images into tables, right? Squish them into tables where I have the coordinates and the energies and the time series for all the objects, and then do some statistical analysis on those, and then turn them into images again, right? Where I would have a plot, a visualization that would show, for example, the amount of variability for a certain object together with its average spectral fingerprint, let's say, to keep it a little bit non-technical, right? And then we see, okay, so there are some objects that are very similar and they show similar variability, and then there's another set of objects in a parameter space that's similar to each other but different from those. And you can try to do some phenomenological physics with those and try to figure out what could be the differences. And in that sense, that those are visual methods that are always applied and that are always used to try to figure out what was going on in my data.
Okay. And now coming back to the original question, and I really linger onto this point a lot, but I see many people struggling with it. Beginners go online and they find this checklist of courses of things you absolutely need to know. Here I need to know Python or R, then I need to know about math, all of these details, and then maybe you're ready to jump onto kernel. And I think your approach, as you described it also follows what I call a top-down learning approach. What are your thoughts there? How should one go about learning when they're also trying to, let's say, put out kernels, or when they're on Kaggle?
Yes. So if you're starting out in that way, it's a similar thing to what I said before. You want to put yourself out there a little bit earlier than what you feel absolutely comfortable with. And you do need a certain set of background skills or a certain set of fundamental skills. You do need some fundamental skills. You need to know a little bit about programming, and it doesn't really matter which language. I mean, I like Python. Python is great. I like R. R is great. Whatever works best for you, whatever flows more naturally for you. And, realistically, Python and R, those are the best options when it comes to data analysis projects and when it comes to Kaggle projects specifically, because those are kind of most common languages that we see in the kernels, Python specifically. So pick one of those, learn about the basics. You want to know about the basics of the programming, about, structures like loops and conditionals, and maybe, some language specific things like list comprehension in Python. You want to know these fundamentals because they're relatively fast to pick up, and they're going to make the later stages of the learning much more efficient. And then for Kaggle specifically, you also want to learn about what drives the different algorithms that we use. right? You don't need to go too much into depth, too much into detail, but you want to have an idea of what's a decision tree. Right? You start with what's the decision tree? Okay, yes, no, yes, no, yes, no. Heads or tails, heads or tails, heads or tails, and if you understand what's a decision tree, then you can understand what's a random forest, and you can understand, what's a booster tree. Okay, booster tree, you need to know a little bit about gradient descent, but again, don't worry about the mathematics too much at first. Gradient descent just means kind of going down the hill, in relatively small steps and going more or less in the right direction with every step. So those are the kind of fundamentals, the fundamental ideas that you need to know when you get started. But then I recommend and I encourage you to get started with a specific project as soon as possible, right? And I think that's what many people will tell you as well. Don't waste too much time on trying to learn some abstract ideas and some abstract notions, but get started with a project. Get started with Titanic. Titanic is very nice, or with house prices, and take all these ideas and all these tools and learn their application for a specific project, because that will tell you and teach you much more about how these methods work, when they don't work on a very specific data set. And for that, it will come in very, very handy if you spend a little bit of time understanding the data set, right? That's where the whole exploratory analysis and visualization will be very useful. You want to understand the data set first, make up your own mind about it, and then you can start using these different methods and these different tools, trying to solve the problem. And depending on what the data set looks like, you will see very quickly which tools work out of the box, right? And which tools might need some data preparation or in order for them to work much better.
You're one of the Kaggle legends, the first kernels grandmaster, and if I dare relate to perfection, your kernels would be the example that are almost perfect. If I dare say perfect, you keep iterating once you put out a kernel. Even after you put out, I think you go through a lot of, as you mentioned, discovering questions and finding their answers. When is a kernel for you finished? After you put out a version, you keep iterating on it. When do you decide to end iterating upon it?
Yeah, that's a good question, and a kind of dangerous one, because the kind of the gut answer would be that a kernel is never finished, right? Once you get into a problem, you can always think of other ways that you could analyze the data, and another ways you could try to model the data. It's never really finished. So the important part is that you have to decide when to finish it. Like you said earlier in our chat, that at some point you have to decide that at this point it's good enough. At this point it's sufficient for what you want to do, right? And my goal with my kernels is to give people a comprehensive overview of the data, right? And I usually stop them at a point where I think that, okay, now this is enough information, and from here people can go and look deeper into certain aspects that they found to be interesting when they were reading my kernel. And there are lots of ideas, so I always kind of keep a list of ideas in just a text document for every competition that I work on. And there are always more ideas that I have for the kernels. Like I could look into this feature in more detail. I could look into this interaction in more detail. And they never stop. They naturally never stop. You will realize that as well when you start working on a project. So at some point you have to decide, this is good enough, and this is sufficient for the purpose of the kernel. And now I want to do something else, or I want to start working on the problem from a different angle. So some of my kernels include models, right? Some basic starter models, like an XGBoost with the basic parameters, no hyperparameter tuning or anything, but not all of them do. So sometimes I do that model on the side and I don't publish it because, you want to preserve at least a little bit of a competitive edge, even if you're sharing a lot.
Yeah.
But for the kernels, try to get to a point where you feel like, okay, this is a comprehensive answer to the question that I want to answer, and there are more strands, there are more kind of ideas that I could follow from here, but I want to leave that to the readers of the kernels. I want to leave that to other people to get their inspiration and to explore these other steps. That's my approach, at least.
Okay. And this also brings me to another question to someone who's just starting out in the community and they are maybe interested in looking into data, creating insights by themselves. They look at the other amazing work, your work. I'd also like to mention some other people, let's say SRK, Shivam Bansal, Andrei Lukanenko. All of us definitely get inspired by your content, your style. There's also a dangerous area where you start copying it and bringing it into your work. What's the right approach there? Because if you keep looking, for example, if I keep going through your kernels, I might just recreate them in a certain way, and that's a dangerous territory.
Yeah, I don't see that as a big problem though at the beginning, because when you're starting out as a beginner, it can help you to have a certain structure and a certain philosophy that you can emulate and that you can start from. But I can guarantee as you go further, as you start to tackle further problems, you will develop your own style of analysis depending on your own philosophy and your own approach to things. So for me, I learned a lot from other people's kernels when I first started out. I learned a lot from SRK's kernel, of course, because they were great. I learned a lot from people like Anisotropic. There was a guy at the time called Philip Spachtold, who was putting out great kernels, great visualizations. He hasn't been around for a while, unfortunately. And I looked at all of those, and I think I in a way modeled my early kernels on all of those different inspirations and ideas that I was seeing, and then over time develop my own style of analysis and develop my own approach, and something similar will happen. It's really inevitable. If you start out and if you look at enough problems, look at enough analysis, you will come up with your own style. So I wouldn't worry about that too much. If you're at the beginning leaning a little bit more on what other people have done, on the structure that other people are using in their kernels, that's perfectly fine. The important thing is that you put your own original ideas out there and you put your own work out there, and from there you can only grow.
Certainly. This is sort of an extreme version of it, but many people might fall into the trap of plagiarizing. So I think they're two different things, and you might agree. One would be taking someone's work and building on top of it. You take their work, you really add some value and share it. And the other is sort of just using it and adding very minor changes to it. And this issue is sometimes visible on Kaggle, especially in beginners who fall into this trap of getting early votes since it's a gamified category. What are your thoughts on how should we avoid that? And I think it's also a misconception that people really want to get a medal, for example, or just want to get to that tier.
Yes, wow. There are a lot of layers to this question. So let me try to unwrap it. I think so. The first aspect, building on the work of others. This is something great. This is something important, and this is something Kaggle really excels in through the kernels specifically, but also through the way that the community interacts. So the kernels give us the opportunity to kind of stand on each other's shoulders. Right? Somebody puts something out there. I have an idea of what to do with that analysis or what to do with that model. So I fork the kernel and I put my own spin on it, and I put it out there, and people can learn from that as well. So that is a great thing, and that is a very, very valuable aspect of the Kaggle environment. Now, the important thing to keep in mind in these kind of processes is that you always want to give credit. You always want to make it clear for people what is your own original contribution and which contribution you take from other people, right? And forking kernels, you can do that. You can say, okay, I took this setup from SRK, and I tuned the hyperparameters. I did some additional feature engineering, and here's what my model does. Put it out. They clearly say I take this data from those sources and those ideas from those sources, and I add my own ideas, and that's what I find. And that's great. That's the way it should be. Coming to the plagiarism and the gamification. So that's something that we keep talking about in the community every once in a while, and it is a problem because the kind of the problematic cores of it are the way that you look at science, the way that you look at data analysis, and the way that you look at your own work. Okay? So where I come from in academia, plagiarism is a big no-no. It can get you into a lot of trouble, and for good reason, right? Because the papers that you write, they are your intellectual output. They are your contribution to the community and to the science. So if you take somebody else's ideas and put your own name on it and then publish it, this is a grave offense. This is a very unethical thing to do, and you get punished for it in the community for a good reason. And this is something that people who, the very few people, the small number of people who try to game the system in Kaggle, they have to realize that what they're doing in that way is unethical. You cannot go onto the internet and find a Medium article and just copy paste it into a kernel and then put your name on it and then publish it and ask people for upvotes. This is wrong. This is unethical. It's not your ideas. It's not your original contribution. You're taking somebody else's work and you're trying to pass it off as your own. This is something that we don't want to see in Kaggle. It's something that I don't want to see. And the other thing is that for the people who are doing this, it's not going to help them in the long run, right? Because they're not actually interacting with the data. They're not actually having.
They're not doing.
They're not
science.
Actually growing. Yeah, they're not doing data science. They're not growing. They're not learning. They're just copy pasting stuff because they think that the upvotes and the medals and even the ranks that they get for these kind of things, that they mean something, but they don't, right? I'm a fan of the gamification system. I'm a fan of the ranking and the medal system in Kaggle. I think it helps people. It helps to motivate them. It helps to motivate me. But all these things, they only mean something in relation to the original work, to the contribution that you put out there, and in relation to your reputation in the community that you build through your contributions, through your interactions, through your questions, through your answers, through your work. Then they mean something, but without that, they don't. So it's a hollow victory if somebody, for some reason, manages to game their way to a master rank or something like this with plagiarized content. It's not gonna last, and it's not gonna help these people in the long run. But people have to be aware of it. People have to be aware of where the boundaries are, because they might look a little bit more fluent for a beginner, right? Many of us, when we do coding and we run into a problem, what's the first thing we do? We check Stack Overflow, right? We found a solution there. Okay, it has 400 votes. Great, that's the thing. And I put it into my code. And that's okay when it comes to these kind of technical things, right? You wouldn't necessarily give a citation to some random guy on Stack Overflow for kind of solving this problem. This is something that we do. We all answer questions, and we all benefit from questions that somebody else has answered. But when it comes to science, and data science is science, that's what I believe, then taking somebody's original ideas or a work that somebody has put substantial amount of time and effort in and passing them off as yours, then that's just unethical. That's wrong. Please don't do that.
Yeah. If I dare add to that, part of this also originates from, and if I can speak to that, the fascination for becoming a Kaggle master, Kaggle grandmaster. I've been fascinated enough to start this podcast for two reasons. One is I want to discover if there's a secret fight club where the grandmasters hang out, which I haven't been able to. No one wants to break the first rule. The second reason is we all look up to the grandmasters as the respected figure, since Kaggle is really the home of data science, and people look at this from a perspective that grandmasters are really good data scientists, and if I can just get that number of medals, I can become a master or I can become an expert. And as you mentioned, you won't be really doing data science if you just aiming for those medals. And ideally those would come along as you gain visibility if you're genuine.
Yes, exactly. So there are kind of two additional aspects I like to mention. And in the sense that the medals and the ranks, they will come automatically if you progress, if you put your own work in, if you're learning and if you're growing. They will be a side product of your learning journey. They will not be the main thing. Because, and to put it in machine learning terms, you don't want to overfit to the medals, right? You can do that. You can overfit to the medals, you can overfit to the ranks, but it's not going to help you in your own personal development and in your own learning journey, because those are the metrics that you want to evaluate your progress on, right? Not just the medals, not just the ranks. You don't want to overfit to the medals. I'm just trying to find a good soundbite. You don't want to overfit to the medals.
Yeah.
The other thing that needs to be mentioned, though, is that the cases in which this happens are really rare, right? And I think we are very fortunate and maybe lucky in the sense that the community that we have is so exceptional in that almost all people are playing by the rules. Almost all people are open and are friendly and are genuine. People are really genuinely there to learn and to learn from others and to give back to others, right? And if you think about it, the most respected Kagglers and grandmasters that we know, right? People like CBMP, like Boyan, like SRK, they give back a lot.
Yeah.
Right? They give us all a lot of inspiration, a lot of ideas, and that's why we respect them, not necessarily because they're grandmasters. This is just a side product of their journey of growth and their journey of learning.
Certainly. I also want to talk about, I think you recently made the transition into doing data science during the day, which I think was last year. Can you talk about that transition? Because you did that after becoming the best on Kaggle kernels, the legend on Kaggle kernels. How was that transition like for you? And how helpful was Kaggle for you in that transition?
Oh, it was very helpful. Kaggle was instrumental for the whole transition. If it weren't for Kaggle, I wouldn't be at this point in my life and at this point in my career that I am at the moment. And well, it essentially began when I joined Kaggle, right? So as I said, I got my eyes open to all these interesting projects that were out there and all these interesting tools and methods that you could use to approach these projects, right? I learned a lot about all the different things that I wouldn't have even considered as a project before, right? Taxi rides in New York, Wikipedia hits over time, all the interesting NLP projects that I kind of got into, and most of them I started really from zero. Right, so the taxi competition, I hadn't done anything with geospatial data before, and at the time when the competition was launched, it was. Right, I looked at it and I thought, this might be an interesting thing to get into, but will I be able to really contribute something? Because I don't know anything about geospatial analysis, about maps, or about coordinates. And then I thought about it a little bit more, and I looked into the data, and I thought, well, if you're already at this point, you might as well, get invested into it. And I tried to quickly learn as much as I could, and to give back in the shape of a kernel, and to show the community and the others who are working on this project what my views were and what my analysis was. And in this way, I became more and more interested in data science that was happening in the real world, right? Helping people in the real world. So I really like these data science for good competitions that are happening on Kaggle every once in a while. I think those are very valuable for people to really make an impact. And that was the main reason for me really to decide that it was time for a change in career. Right? It was a natural thing that I still think that the astronomical projects that I was working on, that they are valuable and that they're very worthwhile, right? And I'm still in contact with my friends and colleagues, and I see what's happening in the universe. But I also think that the data science projects in the real world are very valuable too, and they are a good way for people to grow and to learn more and to grow into a different direction. And for me, it was simply time to go into this different direction and to do something different.
Awesome. Can you share with us what do you do in your daytime when you're doing data science at Edison Software? Can you tell us what all tasks do you work on?
I can tell you a little bit about it. So at Edison, we are a startup that works with email, right? We have a great email app that you can download, and we just launched an email service that you can use. And what we're doing in the data science team is we're doing market research, essentially, on aggregated and anonymous commercial data that we see from our customers, from our users. And we're trying to understand, primarily for the United States, but also for other countries, we're trying to understand how consumer behavior is changing over time and how consumer behavior is changing from place to place for different industries.
Okay, got it. Maybe I'll try to bring you on the show again to maybe discuss in detail about that. But for now, I'll stop my questions there. I want to come back to Kaggle. You're already a legend in the kernels category. What's next for you on Kaggle? Luckily, you're also continuing your sharing of kernels with us for the community. Are you looking at other categories as well? Do you have any other plans?
Yeah, I'm definitely looking at other categories. I mean, I still think of myself as reasonably early in my Kaggle journey because there's just so much to learn. There's so many other things that you can do. I want to get more involved in competitions. So during my first year, I was focusing a little bit too much on the kernels, in the sense of that I was a little bit distracted by every new competition that came up, and I didn't really follow the ones that I was working on. Right? So I want to do more of that, and I want to become a better data scientist and a better machine learner, really, because when it comes down to it, I don't think that at this stage I'm a very good modeler. I'm probably not hardcore in that sense. And although I know a lot of people who are, and I admire them very much for their skill to jump into a new competition and to be up there on the leaderboard.
Yeah.
Right? So I'm reasonably happy with my kind of exploratory skills, and I'm going to continue to work on them, and I'm going to continue to put out new kernels because this is something that I really enjoy. And I want to be a little bit higher on the leaderboards at the end of the competition, because this is a kind of a challenge for myself. And another thing that I'm thinking about is that it would be fun also to team up in competitions, which is something that I haven't done before, partly because, I was in that sort of distracted mood where I was jumping from competition to competition based on, EDAs and kernels when something new came out. So teaming up with somebody, I think would be a very fun experience, and will be something that I definitely want to do in the near future.
Awesome. I think that also exposes you to the culture of data science. For people that aren't already data scientists, that's also one way to understand how do you work in data science teams on real data science problems, if I dare say so. Yeah,
and that's a great part of our community, right? That everybody has a different background, everybody has a different approach, and then if you ensemble those all together, you get something that's kind of bigger than the individual parts.
Certainly. Now, this has been an amazing interview. My final question for you is, what best advices would you have for someone who's trying to utilize their time in physical isolation and just starting their data science or Kaggle journey? If you had to give them one advice.
Well, I mean, right now in this crazy world of COVID that we're living in, I would say one important thing to remember is not to put yourself under too much pressure, right? So this is an unusual situation, and there is a lot of kind of let's say emotional pressure on all of us to deal with this situation in a healthy way. So don't try to do too many things at once. If you want to get started with Kaggle, that's great. Welcome. We're very happy to have you. But get started small. Get started. Pick one project. Pick a starter project, or if you see a live competition that's interesting to you, or where you might have some existing domain knowledge, then get started with that. But don't try to do too many things at once. If you're starting out as a very beginner, if you have kind of no background in programming or in machine learning or in anything, just start with one language, start with one project, and then bit by bit start to build from there.
Got it. Before we end the call, I'll have your profiles linked in the description, your Twitter profile, and your amazing blog, which is another place where you sometimes share insightful stories. Any other platforms that you'd like to mention where we can find you and connect with you?
I'm really most active on Kaggle itself, I would say, in the forums and everywhere. Second to that, I'm probably most active on Twitter. I don't tweet a lot, but occasionally put out some ideas, some thoughts, and some feedback that I also have for other people. You can connect with me on LinkedIn if you're interested, and that's it essentially.
Okay, awesome. Thank you so much, Martin, for all of your contributions to the Kaggle community, and thank you so much for joining me on the podcast.
Thank you for having me. It was a great pleasure.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review, or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.